The 2018 Commonwealth Innovation Forum, brought to you by Destination Gold Coast.
So we're going to move now straight into our next and final panel for the day. And this panel is going to discuss how we might work together to encourage the development of technologies that make our lives and our environment cleaner, safer and healthier. And to tell us more and to introduce our panellists, please welcome our moderator, Heather Bone, the Managing Director of Rebus Sustainability. Thanks, Heather.
It's usually one of the other rooms. Oh. Sorry, I was stuck out the back going from there around to there. Sorry about that. I'd like to welcome my colleagues to the stage. In order of appearance, David, please. We're going to come out of the wings. David Bressler, who's the Professor of Bio and Food Engineering at the University of Alberta. Sean Mackay, President and CEO of the Composites Innovation Centre. Baz Melson, the Director of Biorefining for Asia Pacific for Novozymes. Professor Ian O'Hara, who I'm sure many in the room will already know, with QUT and also the Queensland Biofutures Envoy. Dr. Simon Potter, the Director of Manitoba Genome Prairie. Michael Vivera, the CFO and CMO from Mercurius Biorefining. CMO, by the way, is Chief Marketing Officer. I had to ask him what that was. And Claudia Vickers, who is the Associate Professor of Bioengineering at UQ and also the Director of the CSIRO's Synthetic Biology Future Science Platform. Oh, and I've got a seat left. I'm going to come over and join you. So we might start the discussion. We're going to be talking today about technologies that support a growing bio-based economy and aim to meet the demand for sustainable sources of energy and renewable products. I might actually start, we actually, as we were standing out the back there, Michael and I, where's he gone? And Claudia actually just got into a bit of a conversation about what is the bioeconomy? Even between the three of us, we had a 2-to-1 conversation about what is bioenergy versus what is biofuels. So I might throw to you, Professor Ian. What is a bioeconomy, and maybe you might like to touch upon the recent report that QUT's put out?
Sure. So thanks for the question. Thanks. It's great to be here. So look, I like to think in terms of opportunities and challenges. And certainly as a Commonwealth, as a globe, we face significant challenges. You know, if you think about, we need to create maybe 70% more food by 2050. At the same time, we need to produce 50% more energy in the same time frame. But we have to do both of those two things in the context of also reducing carbon emissions or essentially decarbonising the economy over the same time frame. So when you put all those three things together, it's an incredible challenge that we face. But along with challenge, there are opportunities as well. And we've seen, and in one of the opportunities is the incredible rise in science, and particularly in the science of biotechnology, which has just dramatically changed over the past 10 or 15 years. So we've seen science increasing, the ability to do things we couldn't do before is changing. We've got increasing markets, particularly through the Asian and African continents, and through India. And we've also got opportunities that have been generated by the rise of the informed consumer. So we've got a great interest in green products. So what the bioeconomy talks to is how do we transition from a world that requires fossil fuels for everything, for energy, for all the materials that we have, for the plastics, and how do we transition our economy to use sustainable bio-based resources, or sustainable resources generally, but bio-based resources in particular, to create, through sustainable processes, sustainable chemistry, produce clean, healthy products that we use in our everyday lives. And in doing so, we can help to increase food production, we can change our energy systems, and we can also help to decarbonise. So that's what we're trying to achieve. One of the things we've just done in Australia is to launch a new report. Came out last week, and we launched it at Parliament House in Canberra. And it looked at what the opportunities were to go from, to grow the bioeconomy, transitioning through biofuels to bioproducts, and creating new industries based around these products. And what we found in that report was that there wasn't just one benefit from growing a bioeconomy. We found that there were multiple benefits. And those benefits included job creation. So growing jobs, particularly in our regional communities where it's probably hardest to grow new jobs. And those jobs are in clean tech industries, low carbon, sustainable jobs that will be our jobs of the future. Also that we reduce carbon emissions. So by going to those sorts of products, we reduce carbon emissions. we also some jobs carbon emissions. We also we found that we can take and we can transform wastes into products as well. There are multiple benefits that arise from growing a bioeconomy, and I guess that's what we want to explore today as part of the panel.
Fantastic, thank you, Ian. And I think, by the way, I can see there's a lot of familiar faces in the room. We would love to have your questions. There's a TV down here, so please submit them through the forum, and we'll endeavour to get to as many questions as we have. David, I might come over to you because you're a fairly frequent visitor to Australia, which is wonderful. What makes Australia a great partner in this space? Why do you think that Australia would be a good partner in the Commonwealth for a bio-based economy?
Well, I think, first of all, thanks for the invitations to come, Mario and others. I think the alignment between Australia, Canada, most of the Commonwealth, and we heard it at the Commonwealth Games opening, we've heard it throughout the last week at many of the events, is that it's a mutual cooperation, trust relationship building kind of atmosphere. In the bioeconomy specifically, and Ian hit on this a little bit, it's really about rural resources. So if we get back to our macroeconomics of how do we create wealth, a country that has that bio-based resource to draw on, that can't be exported on a whim to another community. You have the bioresource, and it's really about how do we best get that bioresource broken down into, I've been joked and teased about calling it Lego pieces, but really in the chemistry world, purity is value. And if we figure out how to get our biomass into more pure forms and create value from that, there's a lot of opportunity. Canada, Australia, many other countries in the Commonwealth have biomass. They're looking for that regional development, but it goes back to that mutual trust relationships. If it's industry, government, academia, nothing gets done in the real world. We talked about innovation, mankind. To move a project forward, the people have to trust each other, and I think that's part of the Commonwealth's history.
Yeah, I think you might be right, and I think hopefully Michael would agree. I know that it's taken a lot of time for Mercurius to come, hopefully be working in Australia, but you see a terrific opportunity here.
Oh, I do, absolutely. It's not an opportunity that is recently made. It's an opportunity that we saw a long time ago. Unfortunately, as a business person, we seek stability. We seek, a vision and an assurance that regulatory and government regulations and government policies are going to be stable over a long period of time, or a long enough period of time, that you can actually make investments, grow your investment, get a return, and create a new industry. That's very, very difficult if the government environment that you're dealing with is constantly yo-yoing between one set of policies and another. And for us, one of the reasons that it took so long is that we experienced the yo-yo. We came and there were both federal and state governments that were very positive about what we were doing and about the bioeconomy and about the products that we wanted to produce and about how we cared about regional Australia and how we wanted to grow jobs in those areas. And then it flipped and got a federal government, at the same time almost, got a federal government was very antagonistic towards that idea and was, kind of bent on rolling back what the previous government did. And then the same thing happened in Queensland, and we said, okay, time out, let's move back. We didn't disengage completely. We kept our relationships with QUT, with Life Sciences Queensland, which thank you very much, Mario, for continuing to support and be a champion for us. CSIRO as well. So it's not like we left Australia, but we had to put it on kind of suspended animation until the policy started aligning with what we needed to have to feel confident to come back here, and that's why we're here. The federal government's still lagging, in my opinion, but they're lagging in a way that's so, non-directed that it's not that big of an issue right now.
It's not too offensive.
But the Queensland government has been very supportive, and we're partnering with them to develop our technology, which is a technology that takes waste biomass from agricultural, forestry, and even municipal biomass-based waste, and we transform it into diesel, jet fuel, and renewable chemicals. And we also have something we call the Rescue Initiative, which is very interesting. It's a renewable and sustainable communities initiative, where we put our biorefineries, we want to couple that with TAFEs, universities in the region, as well as social services, so that we start bringing in the people that have already in the system to some degree, and we start building skills so that they can come into the biorefinery at a low level. We can help them create skills that will allow them to grow up through the organization and not necessarily stay. Hopefully they'll go out and create their own businesses, but they'll have this new skill set. And we'll be creating an industry from the ground up. But it needs to be done in partnership. Our company can't do it by itself. It's been proven that government can't do it by itself. And society, private enterprise, or particular social groups can't do it by themselves. So it gets right back to this whole idea of the Commonwealth, this common need to work together and to have stability to be able to do that. And that's why we're here. We're here because Queensland decided to vote in a government for the first time for 4 years. So you got 4 years of stability, and we're going to either prove what we've been about or not, but we're going to have the opportunity, and I'm excited about it. Thank you.
Thank you. I'm a director of Bioenergy Australia, and I've been involved in the industry for 15, 20 years now. I guess it's a bit of a passion, isn't it? You can't escape once you're in this industry. And I'm lucky enough to sit on the boards of a couple of startup innovation companies all working in biofuels and waste to energy. So I absolutely agree with you. The stability of good policy, or stability of policy, so at least you know where the goalposts are, is pretty imperative. Baz, I know Novozymes has been in bioenergy and in biofuels in Australia for all of that time, certainly, and beyond, I think. How do you see what's going on in this space, both in Australia and internationally, given your experience in Asia Pacific as well?
Sure. So in Asia Pacific, compared to the rest of the world, so as Novozymes, we're an enzymes company, and we supply enzymes across many different industries, but specifically relevant to this topic for the bioenergy industry as well. So we supply a lot of enzymes to the biofuels industries in North America, corn ethanol industries, and in Europe, as well as in Southeast Asia and Australia. On top of that, we also supply the majority of the enzymes for second generation biofuels currently and in the future. Hopefully, into bio-based chemicals as well. And for the second generation, it's mainly in North America, South America, and Europe. So in Asia Pacific, we haven't seen any commercial scale activity yet. And from what we're seeing, a lot of it is about policy support and about collaborations between universities, companies, and governments, what one of the previous panel speakers was referring to as well. And we do see that, especially in Queensland, there's actually a lot of good effort from the state government, combined with academia, like here next to me, as well as industry, like people around the panel here, who've teamed up together and are looking at how can we, in the Asia Pacific region, get something off the ground. And in that sense, I think Australia is quite well positioned because it is willing to go a little bit further than what we've seen in other countries in the region. It's, of course, a very different situation. We work a lot in countries like India, Malaysia, Thailand. They're very different policies. It's more about government telling industry and government-linked companies what to do as and when it fits with their policy. Whereas here, I think it's more of a industry together with academia and government trying to figure out what actually works best around the world and implementing it here. So in that sense, I think the innovation element in Queensland, from our perspective in Novozymes, is high in the region, and therefore hopefully will become an example for the rest of the region.
Terrific. I think you touched upon collaboration and between research, between science, between universities. I'd be interested, Claudia, to hear a little bit about how things have changed or transitioned, hopefully, in the bioengineering space over the last decade in your experience.
Yeah, the last decade has just gone at an incredible pace, and it's already been referenced in the previous panel about the things that we can do now that we couldn't do 10 years ago. We can't even predict. I think the chief scientist mentioned this. We cannot even predict now what we can do in 10 years, and that's certainly the case in bioengineering. So we talk about the technologies that allow us to do bioengineering and synthetic biology. So synthetic biology is the area that I'm in, and in synthetic biology we use bits of DNA to build modular devices, components, organelles, and whole organisms up from scratch. And so we design and we redesign living cells. And the tools that we use to do that are DNA encoded bits and pieces. And the two technologies that allow us to do that effectively are our ability to read DNA and our ability to write DNA. And those two technologies are moving much more rapidly, much more rapidly than the rate of integrated circuit development for the IT revolution. And if you think about what we've had going on in IT revolution over a period of a decade, we'll be much further and much faster based on our key technologies that allow us to achieve in that space. So right now, so a decade ago, it's been a little bit over a decade ago, we were just reading the human genome. It cost an enormous amount. It took 10 years. Nowadays, I can go to the lab next door, give them a bit of my DNA, they'll sequence it, give me the results back. It might take me a few days to work out what's going on there, but it's incredibly faster and incredibly more powerful than it was, even 6 months ago, let alone 10 years ago. So the rate of change is very rapid, and it allows us now to start thinking about building genomes from scratch, entire organisms from scratch. And what that means is that we can bespoke design living cells to do these biotransformation processes that convert biomass in a renewable, sustainable, environmentally friendly way into the products that we need. And they might be pharmaceuticals, so high-value product, or fragrances, flavours, food additives. They might be agricultural chemicals. They might be biofuels or fuel additives. There's a whole range of different products that we would like to be able to make, and that we're working on making in an efficient way so that we can actually bring them to market in an economically feasible way. So a really important issue to touch on here is that economics is a really major part of the equation. So for a large-scale product, if we're talking bioenergy or biofuels, then the cost of the feedstock has to be really quite low in order for it to be economically feasible to get that product to market. And those are the challenges that I guess that we face at the moment. So now we're at a stage in bioengineering where we've never been before, where we're able to imagine things that really were not possible previously, on a scale and a scope that were not possible, from really building whole organisms up from scratch. That's a really exciting time to be in.
The previous panel, they asked the question of, what would be one innovation now? And I would love to see, the innovation is how do we get rid of those pesky oil majors altogether? And Sean, I reckon your innovation centre might hopefully be working on that sort of answer. What sort of role do you think the innovation centre might be able to play?
We're not actually, but...
There you go, opportunity.
Yeah, but there's plenty of opportunity. I see the whole biosystem is, and this issue is just one of the types of issues that we run into, is how can you replace, say, a plastic with a biodegradable material, and why haven't we done it? We've been talking about it for years. We've been looking at the biodegradable plastics out there at the moment. So how come we're not using them across the whole different areas where plastics are used? And it's predominantly because we generally they're not capable yet of meeting the requirements of the other plastics, or even what they are meant to be used for. For example, we do a lot of work with bus industry. We've got interior and exterior panels we're trying to make out of biofibers and include with a resin system, bind them together with bioplastics. We can get bioplastics to do that, but they only come they'll only meet a temperature limit of maybe 100 degrees Fahrenheit. When our buses are running down the street in Death Valley, you're hitting 160 degrees Fahrenheit. So they're going to start falling apart. So we still need the technology to drive that. So we as a centre, we basically take that technology and then work with our industry partners to commercialize it. So we do need the researchers to develop those types of resin systems. It's still out there to do that. So I think so the answer to your question is the technology's there yet. We need to invest more into it to be able to be able to have materials that we can then work with our industry partners to get them to use it.
Fantastic. I think we'd all like to see that. I know, Simon, your passion is around the rational design of biomaterials, and this is where you've been working as well. What sort of role do you think that there's a very diverse group on this stage? What sort of role do you think we can play in bringing that together as technology solution providers, as policy?
Well, there's several aspects to that, I suppose. From the biomaterials perspective, as Sean said, we're not really there yet, and I think it's not necessarily a quality issue per se. It's more of a variability of quality issue, and that is because we are dealing with an inherently variable feedstock, right? So really, the kind of expertise that we have around this panel and around the room as well is in maybe looking at different ways in which we can identify those challenges and then address them. I worked in the forest industry for some time in Canada, and I remember that at this one particular occasion when I went to a mill in northern Alberta, and the guy who was running the mill told me that, you can give us really poor quality fiber, and I can adjust my process as long as I understand what it is you're giving me. I can make a quality product out of it, and I can make money out of it. What kills my business is variability in the fiber source, right? So if I've tailored my process to spruce, for example, and then all of a sudden I get a big plug of Douglas fir coming through, my quality drops through the floor and my paper will rip. And if you've ever seen a paper machine in a pulp mill, it's like, across this room running at 60 miles an hour or something like that. The last thing you want is for that sheet of paper to break, right? So basically what we need to understand is we need to get cross-disciplinary teams together to address these big issues. And like I said, variability is a big one for us. Quality is another big one. And really, that's how we're going to start really rolling these biomaterials out commercially, I think, because you talk to Ford, for example, as a car manufacturer, and every time you go to an organization like UQ or something like that has a biomaterials department, they've all got this bio-based car door that they've made, or a skateboard or a surfboard or something like that. Everyone has one, right? And yet it's not been commercially rolled out yet. So we know we can do it, and the auto industry knows that we can do it. They just don't believe that we can make 100,000 doors of that same quality or 1 million doors of that same quality. So really the credibility is where we're going to have to address this. And that's when you're going to start to see these things rolling out. And I think, to answer your question, like the coming together of different multidisciplinary areas is how we're going to generate that level of credibility and trust, as was mentioned in the previous presentation, that the industry needs to see to make these things a reality.
So speaking of variability of feedstock, we've got a couple of questions in front of us, and I actually looked down to see at what time they came through, because it wouldn't be a Queensland forum if we didn't get these questions. And of course they relate to a proposed waste levy. Surprise, surprise for everyone in the room. 2 questions. Queensland recently reintroduced a fee on waste disposal, which actually hasn't quite happened yet, but they're planning on it, or they're discussing it. What role do waste charges have on waste reduction and bioenergy? And the other one, is loosely linked. The Queensland Government has proposed a waste levy with a detail to be determined. How could this assist a biofuture? Ian, I might throw to you because I know that it's something that you and I have been working in this space for a while. What's your sense around a waste levy in Queensland? And we had a forum just last week that this was one of the questions that came up as well. Where's he thinking at now? Biofutures envoy?
So look, what I want to say very clearly is the most important role the government has is to provide guidance to the system. Yes, they'll put in place regulations and legislation, but governments fundamentally tell the system which way they want things to happen. And so what was announced a couple of weeks ago was actually not a waste levy. What was announced was a waste strategy, and the strategy included some reference to a potential levy. So what is fundamentally good is a government sitting down and saying, we have a problem with waste and we need to develop a strategy to deal with waste. That's been exacerbated by the reduction in imports into China, which has really hit the industry very hard. There have been a number of other issues, including waste coming across the border from New South Wales that have been challenges as well. But fundamentally, it's a great thing that we have governments around in Australia, but around the Commonwealth and around the world, saying we recognise this is a problem. Our previous panels referred to waste plastics in the ocean, to food waste. These are issues that we need to deal with. So waste strategies, fabulous. Waste levies are a great way of helping to tip the balance of the economics in favour of actually doing something that's productive and profitable. And so, these are things that governments around the world do use or are considering using to help to tip the balance of projects in favour of actually happening and actually dealing with the problem that we know we have.
Yep, Baz?
Yeah, I fully agree because we are working on a couple of projects, one in England, one in the Netherlands, where our partner has a technology to convert waste into energy and different streams of recyclables. Enzymatic, of course, that's why we're involved. But what's really critical is that there is an incentive for those kind of technologies to be used. Because the cheapest way to deal with waste is to throw it away and dig a hole in the ground and throw it in there. But that's actually not cheap at all in the long term. That's a big cost to the environment. And plus the land you're using and the trucks to bring it there and so on. So if you add everything up, that's actually not so much different from actually having a tipping fee and getting people to collect it and do something proper with it. And so we're seeing that more and more countries, like what Ian mentioned, they see that that's a problem and it needs to be fixed. And one way to fix it is to actually have a levy or have some kind of payment system in place to give innovative technologies an opportunity to come in and recycle or reuse it in a proper way.
David, do you want to touch upon your jurisdiction?
Yeah, I'd like to touch on that. So Edmonton in Alberta has a waste management program, and we've had levies and collection. And I think the clear distinction is if you have a levy, you do not want it to turn into just another form of tax. It gets built into business as usual. People pay a tax and shows up on individual household bills, and you never get anything from it. I think one of the models that's out there is, we have carbon taxes, carbon mandates, carbon trading. Edmonton was trying to be very proactive in this space, and they got into trying to get 95% or 96% rejection from landfill. And that's what led to support for Enerchem landing in Edmonton, which is a syngas back through methanol to ethanol, and is now becoming a platform where ethanol can be used for other components. I think the secret to all of this space is, I love what I do. The secret to this whole space is having a bigger perspective, that if you look at waste or forestry waste or agricultural waste or food waste, if you look at it like an engineer or a chemist and say, what's the dollar per carbon unit, dollar per gigajoule of energy, it's right there and competitive with oil. We just don't have technologies that are refined and so efficient that it's cost efficient at this point. So if the levy creates an opportunity, as Boz said, to push the technology over the hurdle so that it becomes established and starts getting that refinement, you'll find that it will become competitive because the base economics say that your carbon units are cheaper. Your energy is at least in that ballpark. It's just getting the technologies that are cost competitive. And the perspective is really important here. We're used to .com. We want hourly, we want to have a bioeconomy tomorrow. We want this to just explode onto the space. But in 100 years from now, when people look back at this time and look what's happened with the biofuel space, look at DuPont and their Sorona biopolymer, the stuff that's happened over the last decade is revolutionizing this space. And it's happening very quick. It's not happening .com speed, and that's the investment, you hear a little bit of echoing there. But we're just at the start of something really cool. And in the biofuel space, Jim will talk about a lot of this, I think, tomorrow, or a hint on it. We're seeing governments come, governments go, excitement, whining. But every time you get a good time, people expand. A cutback in policy, things go bad. But what happens is you get rid of a lot of snake oil and people that were just chasing easy money. You're getting now happening in North America, and I think globally, some consolidation of companies so that the companies are coming together and they're taking best practices. So every time that happens, it's like a diamond. It gets harder and harder. Those companies that come out of the back end of that are much more competitive. And we're getting close to a tipping point where you see that revolution where it completely flips the gauge. So.
I think, Michael, you must be feeling that tipping point into second or next generation biofuels and renewable chemicals. Do you think we're reaching it?
Oh, I absolutely think we are. I tend to talk about our desire to produce biofuels as that was our goal. And when we get to that goal, we will have also realized better ways to create monomers for plastics, and other chemicals that we know we are capable of producing but aren't ready to go to market yet, whereas biofuels, people want them, and if we can get there in enough quantity and earn enough money, then we can go back and spend that money to push these great other products that will be very beneficial widely in the world. One example is replacing PET with PEF. It's hugely important endeavor. There's one other company working on it. We have a different path. We think our path is better, but we're down the road to get to fuels first. But while we're going there, we get a strategic partner that wants to take this way. That's what we'd like to do. We're working with a couple Japanese companies that may turn out to be the case. What I'd like to say about what David just said and what Boz said, and some of the other panelists about, we're not there with the plastics yet. We're not there with they can't meet the same standards that plastics made from petroleum have today. Well, I got news for you. The first plastics that came out of petroleum weren't all that good. They broke, they cracked, they smashed. They couldn't handle the heat either. It took a long time before, and guess what they got? A lot of support, a lot of government support, a lot of regulatory support. The petroleum industry and the way that it came to dominate a lot of our consumerism didn't just happen by accident. And so what we're doing isn't going to happen by accident. And it's worthwhile to remember that. And I think what happens is, purposely by those that are benefiting from the status quo, is they want to ignore that. And they want to pretend that, no. Right when we found petroleum, it was so great. Immediately. Just poof, everything changed. Well, that's not true. That's just not true. And it's still not true. We're still subsidizing that industry. And I'm not saying necessarily that's a bad thing. We got a lot of good things out of it. The way we live today has a lot to do with how we were able to exploit that resource. But it had all these negative connotations and results that we've basically kind of either ignored, brushed under the table, or out and out kind of distorted. And that's changing. We're beginning to realize, wait a minute, we've got some big problems. So I do believe we're at the tipping point. But old habits are hard to get over. And as culturally, we don't really like change. People get comfortable in their everyday activities and what they use. So we've got a lot of work to do. And I think one of the most important things is getting people to understand the history and how things change and get them to be more accepting that, there was a time when we went around in horse-drawn carriages, and then we went at first to steam, and then there was a fight about how we were going to go the next. Were we going to use oils, or were we going to use alcohols, and it turned out petroleum won that battle. But it was never a foregone conclusion. I think it's best that we remember that and that we communicate that to the communities, because as the speaker before us was pointing out, there's a lot of anxiety and a lot of fear, and it's because humans like stability. Just like companies like stability in policy, humans like stability in their lives. And when you throw something new at them, you're rocking their boat. And it's easy to then increase that fear level. If you've got a perspective that you want to create fear, you can do that. And I think it's all of our responsibility to try to inject facts in a way that people can accept them, and to remind people that we are on a journey that didn't just happen. We made decisions, and things came about from those decisions.
I can see Claudia's itching to.
She wants to say.
She's itching to say something.
Yeah, so a bunch of people, a couple of people have touched again on the economics that I mentioned earlier. And that's a really important thing that bears a bit of examination, especially around the biofuel side of things. So biofuels are a really large volume product, and they're cheap compared to pretty much everything else that we could possibly want to make. And the economics comes into it because you have to assess the size of the market, the cost of the product, and the cost of the feedstock. And those things together come, and they make an inflection point. And somewhere along that line of inflection, you are making the product using a biosystem more cheaply than you can make it using a petrochemical system. And that cheapness might come from government subsidy, or it might come from better chemistry, or it might come from a whole lot of different things. But at that point, you have an economic tipping point, and you can actually start competing, and you can make that product. Now, biofuels, obviously, is the most difficult thing that we can try and make in a biosystem, because there's a lot of it needed to do anything sensible, and it's cheap. And you're competing with petrochemicals that have 100 years of investment behind them to get them where they are now. So there's a really nice example that I like to use here, a company called Amyris. They said, American company out of California, comes out of Berkeley, and they said, right, we're going to make this product called farnesene, and it's a jet fuel, it's an aviation fuel. We're going to go for the aviation market because it's a higher quality market, it's a higher energy density, slightly lower market, and we've got this great molecule and we're going to make it. Went really, really hard. A lot of excitement, enormous amount of investment. Didn't really get there in terms of a cost competitive product. Got almost there. Got to a product that they can put in a plane and fly around from place to place, and it is actually approved by the International Air Transport Authority, or the body that does the approvals for aviation fuel. Great, so they kind of got there, but they really didn't make it cheap enough to compete with a petrochemical. Fortunately, that exact molecule, which by the way smells like green apples, is really high demand chemical for fragrance industry. So they have a product that they can divert into a much higher value market, and they can do really well out of that. The technology that they developed to almost get to biofuels using a really intensified yeast fermentation system, we can use that to make 100,000 other amazing products that have a different market size and a different price point that we can bring to market. And all that investment that went into making that product is delivering a whole lot of other products in a bio-based economy.
And we absolutely find that with so many bio-derived and bio-based products, don't we? That the co-products are actually sometimes more valuable than the original product that we set out to make. There's a question from Lawson. I might throw this to you, Sean, if I may. What role does the panel see for the sort of precincts around science, technology, knowledge, those sorts of precincts? They're in their infancy in Australia at the moment compared to the UK and the US. What sort of role do you see for that, your sort of centre, and can the precinct participants assist in a way of preventing the cannibalisation of precinct specialities?
Okay, I'm not sure what you mean.
It's a tough question.
I'm not sure what you mean by precincts, but...
I think Lawson's sort of talking about, maybe not the Innovation Centre, but precincts similar to the ones that we're finding in Queensland, where science, technology, knowledge is all coming together in the same sort of space.
And clusters.
Yeah, clusters. Okay, I feel it's... if we look... I'll do the Canadian example. if we look and try and, if we say, I want to make this jug out of natural fibers. So, sounds pretty easy. Sounds like you've got and so if you've got a crop on the field that you're processing, you can take off, you've got the stem there, you can break it up, you can get the fibers, you can combine it with maybe a resin system, and you've got your plant. So now if I do this in a single setting or a location, which is a group, and I'm assuming this is in a scientific area, or say a scientific, like a university, for example, and combined with a college system, and they basically bring the people together to develop it. You've got so much different nuances that you have to overcome to be able to make it happen. You really can't do it within a precinct. You have to do it within a series of precincts, and those have to be combined with industry and others. So it's not really, and I think it gets back to the collaboration issue, is you've really got to start collaborating and joining these things together. If you do it within a single location, you're never going to get it done. Example, I've been in Australia. I really love coming to Australia. We've been collaborating on biomaterial commercialization, I'd say, for the last 11 years. Have we got anything commercial yet? Not yet, no. Have we developed a lot of knowledge? For sure. Do we know what the question is or what the gaps are and what needs to be filled? Probably 80%. Are we working on those? And the reason why I come over here and work also in China and in the US as well, and into Europe, is because we need a large collective to be able to do this. And that's why I think that this Commonwealth theme of the conference is very good, because we need to get this collaboration happening, and much more rapidly than we have in the past. And we need to throw a bit more money at it to make it happen as well. So for example, going back to the example of the biofibers, so Simon brought up quality issues. So not only we do have a huge variation in a fiber, I can have a fiber that I can snap my fingers, or I can have a fiber that I can actually tear my fingers apart because I can't do it, and they're from the same plant, maybe from a different part of the field. So how can you actually understand that quality and deal with it? So we've got UQ. They've put a statistical design method together to deal with that. So, but now how can we test for that? So now in Canada, we've got a national bioproducts quality network that's developing quality standards for that. Now, how do we actually get the farmer to actually get a good material off the field that can produce that quality? We've got agronomic practices going now, so that we've got growing practices, and then you take it through to the processing facility. We've got now starting sensors being put in. We've got AI to interpret that. So we've got Internet of IoT, Industry 4.0 coming on, but still a whole whack of stuff to do. And then you get to the next step of the thing. Well, how do I make that fiber into a mat that I can make into my? So then you talk to the mat guys. So you've got all these supply chain issues going on, where they need technology, they need they need an economics, they need to be economically viable. And we need to really understand the variation. So you've got all this kind of going on, and so our organisation, it's only 30 folks. We're collaboration with UQ. We're trying to put a little centre over here that's similar to ours, to actually interface between the industry and the university system, to actually trying to commercialise things. So it's really a rambling answer, but it speaks to the fact that it's down to the details, and it's down to the nuances, and we will not get further ahead unless we collaborate. And there's a lot of we have to be, there has to be a good understanding between government, industry, to be able to see how we can take it forward, where the readiness of the technology is, and where you really need to put some incentive behind it to be able to make it happen.
Let's take an interesting step away, Simon. I'm going to throw this question to you, so I thought you've been thinking about it. Let's take a step away from collaboration for the moment, because Kate has given us a question about, are protectionist IP laws and policies in the Commonwealth slowing down innovation? If so, how can we overcome this?
Okay, actually, sorry, can I just comment on the
yes,
last question
absolutely.
first? Because I was thinking that through there, and the question was about integrated science and technology. And I think one of the key things there is that we have to take this refining approach to things, because if you don't have that integrated science there with different disciplines, which is kind of what I was talking about before in my answer for the rational design there, which I don't think I answered particularly well, but anyway, really the key is that, if you're a flax breeder, for example, and you want to produce oil seeds, you're not going to really want the plant to energetically waste its time making nice fibers at the same time, right? But if you're someone who wants to harvest the flax plant for its fibers, then you don't necessarily want it to be wasting its time on oil seeds that much either, right? So the total utilization of plants and the refining aspect is how we're going to really get to the value of the co-products and everything, right? And it's really having those multiple types of expertise in the same area where it's so, if you're actually breeding for biochemical recalcitrants or something like that, then what's that going to do to the other co-products that you want to get out of it? And those conversations need to happen probably within precincts of the type that you're talking about. So sorry, that was what I wanted to say on that particular topic. Protectionist IPs, laws and policies in the Commonwealth. Well, I'm not sure what the laws and policies across the Commonwealth are, but from Genome Canada's perspective, for example, we don't take any IP position on things. We would rather the companies rolled out the technologies and made money for themselves. There's a couple of aspects to the IP issue. With big pharma companies, for example, they obviously want IP because that's how they feel they're going to make the money. But then, does that make it too expensive for people to actually utilize the products, right? And how long can you protect IP for? So, I think it's kind of a complex question there. I think you could see it as being a benefit because people want to target the IP and they want to own the IP, so that's a driver for it. But again, you don't want it to the point where it's such that it's unable to be used, right? I went to San Diego a little while ago, and I visited Illumina, the company that makes all of the sequences that 23andMe and Ancestry DNA and everything uses. And they have a patent wall there that's probably about the size of this room with hundreds and hundreds of patents on it. I don't think that's slowed down their innovation at all, and I don't think it's really slowed down anybody else's innovation either because they're able to use these products, right? So, like I said, there's probably two sides to that coin. You don't want it to be too protectionist, but you also don't want to stifle the ability of people to make money out of their innovations either. So.
And the patent laws are not all that defendable. I mean, there's much more value in trade secrets and things like that than there is in IP, because everyone can look at the IP, and then all you have to do to get a different patent is change a distinct part of that IP and go down the road. So I'm just not sure that this is actually a real issue.
Actually, if I can just add to this. So, I mean, the patent system has a purpose. I mean, it's a 20-year window. These technologies, the beauty of these technologies is they're resource-based. The downside is process-based technology. We're commercializing forged hydrocarbons. It's 15 years from original idea to commercial build-out that's happening next year. So 15 years later, you're getting a patent life of 5 to 6 years. You shouldn't be worried about this. Going back to the earlier question about regions losing their value, the reality is, if somebody in the world has an oil field, they're going to tap into that. If you have a biomass resource, the downside of these markets is they're big and low margin. The upside of these markets is they're really big. And so anybody that has biomass, when a company has the ability to transform it and does it economically competitive, they're going to be landing at every site they can. And the beauty of the Commonwealth, back to my first question, is we have shared values, shared legal systems. We have a lot of synergies. Companies understand that. And so sometimes in life, it's really good to be a quick follower as opposed to the pioneer. And I think we're going to see this as one company starts to land, as soon as it goes commercial and has a productivity, you're going to see it going plop, 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 plop everywhere that has economics. So you shouldn't be worried of a bio-based process leaving your jurisdiction. If you have the biomass, they'll want to come for it.
Yeah, so I'm going to connect the question just before and this question about IP, so collaboration and IP. So one of the things that we're doing at the CSIRO Synthetic Biology Future Science platform is developing an innovation network across Australia and accessing all that expertise and innovation throughout the universities, partner organisations and CSIRO and building new ways of collaborating. The very first and major stick point is IP, right? So the way that you have to approach that is actually to build new models of engagement around IP and new collaborative models that come back to who owns the IP and who gets benefits from the IP. And we've developed some really nuanced approaches to that, which have broken down those cultural barriers that exist between the organisations that we're trying to work with, and have been really successful, and have meant that we can get on and do interesting science and get things contracted without getting caught up on who owns the IP and who's getting value from it. And there's a bit more recognition as well of different KPIs in organisations and how you bring those together and how you respect those as part of that process. So I think that's it's not necessarily a mutually exclusive part of the argument. I think the collaboration and IP are really important parts of the discussion. And I just wanted to add on to the question about streams and diversification of crop plants and making sure we're using the whole thing. So bioindustry 4.0 of the future, what we're going to be doing is actually engineering systems, be they plants or whatever, that we can get to switch to go in different manufacturing directions. So, okay, this season we're a bit short of water. Instead of making an oil seed, we're going to put that photosynthetically fixed carbon into making a fibre product instead in that plant. And we're going to be able to change that in response to climate change, changing environments and changing needs in the market. So that's what sort of products we're going to be able to, the level of control that we can have over engineering biology going into the future. And that results in a far more sustainable, environmentally friendly output at the end.
I'm conscious of the time, and I think we've probably got time for just one more question. I can see a little pair of feet off in the wings there, and I suspect it's Madonna, and she's going to come on stage and lynch us off. But I would like to just ask every member of the panel just one last question, and that is, if there could be one thing that, in your mind, would make the success of this industry, and for you, if for everyone here, that industry is different. It's the bioeconomy, it's bioenergy, it's biofuels, it's bioplastics, biochemicals. If there could be one thing to bring success to that industry, what would it be? We might go along the list if we can, David.
Okay. I think I'll go back to my earlier comments. I think it is succeeding. I think it's just perspective in time. But I think the key answer was on the table earlier across the board here that we need stability. Good business case, bad business case, policy certainty, regulatory certainty, setting up accessible playing fields where there's a linear approach to actually building out a plant, and stable metrics so you can build a business case is really what this space needs right now.
Yep, absolutely. Sean?
I think patience, because the number of nuances in there, the understanding of what really needs to be done to be able to create an industry. We've got the government it was talked about before in a 4-year, if you're lucky, cycle. They want wins, so we have investors. So there's the bioeconomy, especially on the bioproduct side, is not venture capital is not it's nowhere near the game plan on the ROI. So you need patience by industry, you need patience especially by government, and all the way through the supply chain, including the farmers, that understanding that this is going to take time, but if we were and recognise that we're on a journey.
Bas?
Yeah, we always say in Novozymes we spend about 14% of our 2 billion euros revenue per year on R&D. And we started investing in biomass conversion in 2001 until today, and we've spent hundreds of millions. And we always say this is not a sprint, it's a marathon. And so it takes perseverance and resolve, and not only from the companies, but also from governments. So, all the points that were made, it's very important for industry. It will happen. It may happen a little bit slower than we thought it would. We thought we would have a huge industry already by 2015. It's taking a little bit longer. Different market forces in play and so on. But it also takes some resolve from governments in terms of what they want to do and how they want to provide an environment for industry to come and invest. How can they guarantee offtake so that you can raise debt more easily and so on. But sooner or later, those things will fall into place, and the faster all the actors have that resolve and put in place those different policy measures, the faster it will happen. But yeah, we have to all continue to do what we're doing. That's our position.
Ian?
I'll just really say the same thing. I think the bioeconomy is coming, and that's despite government, despite competitive industries, despite all of the challenges the bioeconomy is coming. What governments can help to do through policy and through policy stability is to accelerate the development of that. And the one thing we do need is we need to show success. So we need some good examples of success in the sector, and that's again where governments can support to say, let's get those first 1 or 2 projects up and running. Let's show that this works, and then the rest of the industry will flow on from there.
I might add in courage, perhaps, being courageous, being stubborn. Simon?
I'd just add to that too. I think the most important things that government can do is to create that legislative environment whereby it really promotes the industry, and they can do that with things like the CAFE standards, the fuel efficiency standards that they incorporated into the European Union there, really drove the lightweighting of vehicles and the incorporation of biomaterials into those vehicles. Right, so it was kind of a tangential policy, but it encouraged the industry that way. And I think the other thing that governments can do is something like they did with the Biopreferred program in the US. I don't know exactly what happened to that, but government procurement programs saying if we can have a greener version of something, we must buy it. I think is a good way of encouraging the industry as well.
Thank you. Michael?
Well, I get back...
One thing, Michael, I know what you're going to do. One thing.
No, I'm just going to say that without the support of the public, the government is not going to provide these wonderful, visionary policies. The reason the governments do what they do is because the public is split and divided, and they don't really understand it, and they're easily made to fear it. And once they fear it, then they're easy to push them one way or the other. So I know no one kind of talks about this that much, but I really, 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 really think that beyond just, I shouldn't say just, but beyond the fact that we need to have governments making policies that are stable and consistent, we need to have governments that realize the importance of educating the populace about the possibilities and ameliorating the fear. Because until we start doing that in combination with the other things that everyone said is absolutely clearly correct, we won't get there, because there will always be a group that may get into power and they'll want to go another direction. And if people don't have the ability to see the possibilities, then they'll be vulnerable to doing the switch back and forth. So I would say educating the public is very, very important.
Claudia?
Yeah, that's a really fine point. You stole my thunder a bit, so I'll leave you with that point. But I'm actually going to go a wee bit techie, being a scientist, and I'm going to build off a couple of comments that have been made in other panels as well as here, and to say that the innovations of the future do not come in biology or information technology or engineering. They come when those things come together. So I'm a biological scientist by training. I've got to go learn about machine learning and artificial intelligence and how that's going to help me design better and more efficient biological systems. So bringing those together and breaking down cultural barriers between disciplines to create environments where innovation can happen here at the cutting edge, not here at my cutting edge in biology, but here at the cutting edge of innovation, that really needs to happen. And support for that to develop is what I think we need.
Well, please join me in thanking all of our panellists. Madonna is very keen for us to wrap up, but if you could thank David, Sean, Baz, Ian, Simon, Michael and Claudia on behalf of Life Sciences Queensland. I think they've done a fantastic job, and I really hope you've enjoyed the last session for the day.